and then, oh crap, the project is right around the corner for the next one. So I have to fix quick, get something.
Okay, so here's, because I am the department's hard ass, look, just turn this in when you can, okay, before the end of finals. No, seriously, I want to see everybody get a good grade. So if you want to go back and revisit previous projects, go right ahead. You have some flexibility is what I'm saying.
Should I ask the question I had about you and I talking yesterday, Professor?
Which question is that, Thomas?
It's one that came up as I went to coding and getting everything set up overnight.
Okay.
And it's basically, you gave me advice to do some, to specifically do some arithmetic with with addresses.
Yes.
And I'm wondering how I would branch using the address I did the math to, or
okay. Let's see. Give me a second. Well, there is a, hang on. There is a branch. You're still getting an echo?
Yeah, yes, we are still getting an echo.
Okay, now?
You should be good.
Good. All right, well, there's a branch from a register instruction.
All right, and I probably need to use that because I was just using the regular branch instruction.
Yeah, so the idea is, well, why don't let me make sure I've still got this running.
I don't think you've shown us how to branch from a register yet.
Yeah, okay. All right, so let me show where is, God damn, what an awful UI. Every time I experience it, just reminds me of how terrible the Mac UI is. I'm still, there's the meeting. Okay. Okay, so I'm going to summarize what Thomas and I went over. And so we'll see how much that helps, right? So there is a way to transfer 32 bytes at a time from memory or to memory. So LDRP for pair.
I actually got a lot of errors trying to do LDRP.
What kind of errors?
This doesn't exist kind of errors.
I think it's LDP.
Right? Yeah, what's the, yeah, I thought it was LDP.
Not LDRP.
Oh, okay, sorry. Well, it's been like 5 minutes since I've worked on this, so I've forgotten already. So LDP, Q0, one Q register, another Q register, a place to get the data from, and then an increment of that X register. Okay. And then STP, yeah, that's right. You're right. Sorry. Q0, Q1 into to the memory location pointed to by the other X register, and then increment that address, right? So consider these to be a pair, load store pair, right? And this is one instruction. It's 4 bytes long. This is another instruction. It's 4 bytes long, right? So a pair of these instructions is 8 bytes in length. So the reason why I brought the Duff device in is how to handle the initial copying. So let me write down. So here's a pair. Here's a pair. Here's a pair. Here's a pair. 1, 2, 3, 4, 5, 6, 7, 8. And so each of these P's is standing in place of an LDP and an SDP, right? So the idea is, so there's some setup here and a branch. And then over here, there's some loop maintenance, and including another branch, right? So the idea is you figure out up front how many 32s can you transfer, right? And the answer is going to be 0 or more. So if your goal was to transfer 7 bytes, then it's 0 32s, and you'd skip this entirely. If it was 35 bytes, you could do 1 transfer of 32. If it was thousands of bytes, you could do many, many transfers of 32. But the idea is you are going to figure out ahead of time how many 32s can you do. So let's say this is the total number of bytes or the size. And how many 32s can you do? Well, that's going to be pretty much a simple division. So let's take 15 bytes divided by 32, that's 0. Okay. Let's take 32 bytes divided by 32, that's 1. So you can do 1 transfer of 32. So the Duff device comes in here is that you're going to calculate based upon some label. You're going to calculate how to branch into this loop, into the middle of the loop, to take care of the residue, and then let the loop handle all full transfers of 8 times 32. So in the case of the Duff device, you'll remember the following labels in the switch statement. It was case 0, 7, 6, 5, 4, 3, 2, 1. So if you had 1, we're working on 32 bytes, right? So you could do 1 transfer of 32. Your initial entrance into the loop should be here, where the very next thing is the loop maintenance, the loop control, and that will recognize, oh, we're done with 32s. Let's say the number of bytes was 300. Now I want to do somebody tell me what 300 divided by 32 is? Integer?
9.
Okay, 300 divided by 32, that's 9, right? So let's configure the 9 as 1 full loop of 8 plus 1 initial residue, for lack of a better term. So here's your 9. So 9 mod 8 gives you the 1. So you know that you want to jump in again at the 1. You do your extra residue. You do the leftover first, and then you notice that you have enough left over to do a full loop, and there's your 8 more. So in total, you've done 9 transfers of 32. Right now, what is the remainder, by the way, of the division? 300 by 32. So 300 mod 32?
12.
12? Okay. So notice that once you've done all your 32s, all you can possibly have left is 1 transfer of 16, 1 transfer of 8, 1 transfer of 4, 1 transfer of 2, and 1 transfer of 1. Right? So if you had more than that left over, you would have handled it in the 32s.
That already helps a little bit, like just the way you explained it there about why you said that there's a 1 of 8, a 1 of 4, a 1 of 2, because otherwise it would be a 32 and it would loop through again.
Right. So let's say you had 2 2s left over. Well, you would have handled it in the 4. Right? So if you do it in that order, you're eliminating, well, you know, what is the, in binary counting, 31 is 16 plus 8 plus 4 plus 2 plus 1, right? So if you have 32 or more left over, then you would have handled it in the 32s. So the only thing you have, after doing the Duff device, transferring 32 at a time, the only thing you have left has to be less than 32, which means there's at most 116, at most 1/8, at most 1/4, etc. Okay, and that's the whole program. The rest is details. You know, doing the mods and doing the divisions. Now, calculating the branch. So take a look here. I'm going to repeat it. Going back to the duck device, the cases started out at 0. Interestingly, not at 1 or 7 or 8. Excuse me, I'm just writing stuff with no rhyme or reason. 7, 6, 5, 4, 3, 2, 1. So there is a bit of a special case. If the mod is a 0, then you want to just branch in at the actual label that you have. Let me, you only need 1 label here. So here is the label. You only need 1 label. Because if you wanted to branch in directly into the 4 case, you would have the address that you want to branch to. So you load the address of LAB, and then count how far you've calculated how far into the table you need to branch in. So 1, 2, 3, 4, 5th. You want to branch in at the 5th pair. So 5 times 8. Where did the 8 come from?
It's 8 bytes
Per
per.
pair. Right. So 5 times 8 is 40, plus the address of LAB is the address of the LDP instruction. So you just want to branch to that.
How would we get the inverse to work? Would we have to do some subtraction with the remainder of subtracting 8 by the remainder to basically see how far we add things?
Whoops, it's not 5, it's 4. And the answer, Thomas, is what's 8 minus 4?
8 minus 4 is 4.
Ta-da, you figured it out. Okay, so let's say you wanted, you needed to pick up 3 residual. What's 8 minus 3? Right, so in essence, you have the number of residual that you want to capture, right? So you're just inverting it relative to 8. So let's say you only wanted, you had a remainder, you had a mod 8, mod 8 is 1. So 8 minus 1 is 7. So you want to skip 7 groupings of 8 bytes each. It's just a subtraction from 8 to reflect it.
And this is something I asked over email. Why in the Duff device do we see 7 being added to count before we divide it by 8?
Okay, so the way that they structured their code, this would be Tom Duff, structured his code, is the loop maintenance would subtract and branch again if it was greater than 0. So because the subtract was happening, you needed to start out with, it's simply the way he structured his code. So n plus 7 divided by 8 is guaranteed to give you a 1 if the value that you have in n is anything less, anything other than 0 and less than 8. Right? So if n was 0, this will generate, this calculation returns 0. So you don't do the loop at all. You have no need of the Duff device. Right? So anyway, this calculation goes into telling you how many times through the loop you need to do. Okay, so I mean, is this seems like magic to you? Does it?
It just takes me a moment to like digest it. So it is really helpful going over that
Right.
for me at
Yeah.
least.
Yeah. So let's say, once again, the code in the Duff device could be modified so that n over 8 could have been used. So for instance, at the bottom of the loop, if the value you started with was 0 or less than 0, then don't branch. But the way he designed his code, to go through the loop once requires a 1. Okay. Given this, this project should be straightforward. It should be very straightforward. The pedagogical goals here were, this is the very first time you're treating instructions as addresses and data. And part of what this project is supposed to teach you is that you can do address arithmetic on instructions. And one of the benefits, by the way, of the ARM instruction set is that all instructions are the same length. If instructions were of varying lengths, this would be much harder.
You never covered how we would write the command for branching to an address using a register.
Well, I did give you manuals, though. Did you look through it? Okay, Thomas nods his understanding that the information was given to you on day 1 of the class. You just had to go find it.
Yeah, and I'm pretty bad at finding things occasionally, and I may have glossed over it multiple times.
Mm-hmm. So there is an instruction to do a branch when the address you want to branch through is held in an X register. Okay, so what I definitely do not want to see is any code that looks like this. Here are your pairs of load store, and you have a label on each one. L3, L4, L5, and I do not want to see that, where you then code a switch statement. You know, if you intend to jump in here, then branch to L2, that's going to be major points off.
I had another question. So just clarification regarding externs, because I've never actually like really used them.
Mhm.
Since we have the main file being C++ and we have the extern declared there, in order for the C++ file or just the compiler to recognize that they want to use our assembly file, we, instead of doing global main, we do global memcopy in this case, right?
That's correct.
All right.
Yep. That is correct. Let's talk about P5 for a moment. The scores were disappointing. For a number of you, when you're trying to compute the timings, you divided by a million. And, microseconds divided by a million. Not there. You take the number of bytes divided by a million, something like that. And that's wrong, because that will give you the wrong answer. We're talking about megabytes, so that's a power of 2, not in 1 followed by 6 zeros. And I thought to myself, boy, is it really harsh to take off 10 points just because you divided by a million instead of 2 to the 20th, which is a different value. And I thought to myself, you know what, God damn it, the whole purpose of this was timing. If your boss said, figure out timing code, and you came back with the wrong time, then the patient died, right? I mean, that would be a major foul up. So, God damn it, I am going to take 10 points off for dividing by the wrong number, because part of this project was the timing. So you better time it right. And besides, this is your bread and butter. You better know what the powers of 2 are. Okay? So go ahead. Like I said, if you want to take another crack at P5, go right ahead. And let me know by email, because the information I get from Schoology is terrible. I can't. It'll say 1 project resubmitted, but I can't figure out who. So you got to send me an email that says you resubmitted a project, and I'll be happy to grade it. But your juniors and seniors, I'm going to hold you to a higher bar. So your scores were disappointing. Some of you didn't follow the spec at all, and I gave you 0. So, and you know what? You know who I'm talking to. Your work was good. You had a lot of good work there, but it didn't follow the spec. So should I give you a 0? And I thought about it. Is that really fair? And it's like, you know what? If your boss said, give me apples, and you gave him kumquats, you'd be fired. So that 0 of yours that I gave you, this is the most gentle environment in which you can fail. Because once you leave college, you would have been fired. Your ass would have been on the street the same day. So if the spec says jump, you fucking jump. Do you understand? And this is not me being an asshole. This is me giving you a taste of your future career. The patient died because you felt like doing something different. Am I making myself clear to everybody?
Yes.
Someday, literally, someday you will thank me for being such a butthead. Okay? I don't want any dead patients traced back to me. No airplanes falling out of the sky because one of my students felt, hey, what the hell? I don't like doing it that way. I'm going to do it this way. All right. So feel free to resubmit P5. Let me know when you do. And of course, if you're going to be late on P6, don't stress it. Don't be too late. Get it in when you can. Okay? Okay, so more project questions.
So in your spec, you were talking about in one little paragraph snippet thingy, you were talking about cache lines. What exactly is a cache line?
It's the basic unit, the size of a basic unit of cache. It's
Okay.
called a line for some reason. So there's a difference in the level of your game when you can write fast code or optimized code, and then a whole nother step up when you start thinking about, can you optimize it further based upon knowledge of the cache in the processor? So if you can organize perhaps the innermost loop to be in a single cache line worth of instructions, then your code is going to be could be orders of magnitude faster than if you had not. Okay. Now, who is it that needs to pay attention to this stuff? I would say every programmer needs to pay attention because I can't tell you how disappointing it is to get a brand new computer, which is faster than any personal computer anyone has ever had before, and the shit still flow. Why? Because those other people didn't have instructors as butt-headed as me. And they kept, they never, these programmers are not considering the cost of their code. And code just gets slower and slower and slower. You know who the worst offenders are? Google, Microsoft, et cetera, et cetera. They are the worst offenders. If you take a look at the call stack of some major web application, you'll find that the call stack is 200, 300, 500, 1,000 functions deep. Because this schmuck called this framework saying, look, it's just one function call. And that framework calls these 9 other frameworks. Look, it's just one function call. It must be fast. Bullshit. You have to know the cost of what you're doing. So the best programmers will know the cost. And knowing the cost is part of what this course is about. Yep.
We all
JavaScript
should,
is the worst.
we all
go
know
ahead.
the joke about Google eating your RAM.
Right. Right. Yeah, Google's the worst. They can take anything and make it run dog slow.
To the surprise of no one.
Yeah. Okay, so project 6 questions.
So would I be able to ask, so I guess some of the confusion I'm having is when I look online about what exactly like jump tables are, I'm seeing a lot of conflicting resources. I guess, do you have any specific ones that you recommend that we can keep referring back to when we're working on our projects?
On this project, it's okay. So there's there's two definitions of jump table that you might see. Well, I have no idea what it is that you see, but a jump table might look like this, and this is what you'll find in operating systems. So there might be some setup code to do the calculation of which instruction to jump to of the branch destination. And so here's your label. And then a jump table in an operating system might just look like this. Branch here, branch here, branch here, or branch here. And the notion of the jump table is based upon this calculation, you branch from here to wherever that goes, and then that returns to the user. So this is the canonical jump table.
So a Duff device is similar, but also not, correct?
Yes, exactly. So the Duff device is also a jump table in that you're doing a calculation to determine where to branch to. And then you're jumping into the middle of what looks like a loop. And that's really, if you see any definitions, Jacob, more complicated than that, then there's just too many words.
Okay.
Right? So where might you see other examples of a jump table outside of an operating system? Well, one of the lessons that we can have in this course is just on the switch statement. And the switch statement in a modern compiler is phenomenally sophisticated. It will generate different code using different techniques based upon whatever your cases are. One of the things that it will do is, suppose you had case 0, case 1, case 2, case 3, case 4. The compiler, noticing this, would actually generate a jump table. Because if it can calculate, based upon these consecutive numbers, the address with which to branch, it'll actually do that. So that there's no, what is a switch statement at worst? If, else if, else if, else if, else if. Here's a case where the compiler notices it could replace all the ifs, all the else ifs, with a calculation of an instruction address. So that's where your code, so you may have routinely bumped into jump tables without knowing it. Know the cost.
So quick question kind of relating to that. I've noticed in a lot of the example code you've given us, a lot of your labels or variable names are like 1 or 2 letters. Does that save time in any way, or is that just you wanting to write less?
Well, I'm a very strong advocate of using expressive variable names. And I really am. Electrons are free. God damn it. I had salad for lunch. Now I got lettuce in my teeth. Yuck. Really. Okay. So I really am an advocate of expressive variable names. But in teaching, you do this shit all day long. There's only so many, there's only so many different ways I can name the variable I in a for loop. So do as I say, not as I do. I also don't give you comments. And I'm a very strong proponent of commenting. So in general, I don't distribute commented code. I have this naive hope that you'll study the code and figure out what it means. In other words, write, at least mentally, your own comments. Okay. So for code that I'm writing for my own production use or important use, yeah, it's commented and it's got expressive variable names, even for loop counters. Okay, other questions about P5 or P6?
I'm still not the fully 100% on threading, so could we go over that a little bit more for me?
Well, we definitely will go over threading in more detail on a number of levels. Now, so the threading part of this course isn't finished. You get P5 is kind of a teaser of it. And so P5 is using C++ threading, which itself is built on top of pthreads, which is an abbreviation for Posix Threads. So with C++ threading, why does the iPad get stuck? I'm trying to scroll right now, and then all of a sudden it'll start scrolling again. There, okay. So with Posix threads, the way that I've shown them in P5, so P5's version of threads is a thread is launched by calling the thread, the C++ thread constructor. And that's all there is to it. You call the constructor of the C++ type thread, and that launches a thread. Now, when you dig deeper under the hood and perhaps use the Posix thread functions themselves directly, you find that there's a lot more flexibility. For example, you can create and execute all the overhead of creating a thread, but not launch it until later. So for purposes of P5, simply calling the constructor launches a thread. Now, what are the things that you need to launch a thread? Launch a thread. You need the entry point and any possible parameters. That's it. That's all you need to launch a thread. Now, the entry point is the most important. And that is, where will the thread start running? So that is in the form of a function name. Now, the name of a function is a pointer to the function. So the entry point is a pointer to code, which in C and C++ means simply it's the name of a function. So what happens when a thread is launched, here's your address space. Okay, so here are some dragons. That's address 0. Here's your code. And here are your globals. Oftentimes people overlook the line between code and globals. That's fine. And then here is your heap. Here is your stack. To create another execution unit within your address space, all you need to do is allocate another stack. So it's the stack that differentiates one thread from another. So it is quite literally the case. So here's a big range of huge area of dragons. it's quite literally the case where your area of dragons is just divided. So here's the stack from the original thread. So we'll just start another stack in the middle of where the dragons were. So here's this thread's stack growth area, and here's this thread's stack growth area. Notice they're in the same address space, which means that they can, all of these threads can freely draw upon the same globals. Draw upon the same heap. Now that is in distinction from multiple processes. Processes are launched by fork. The difference between a thread and a process is whose address space is it? If you're sharing address spaces among multiple concurrently executing tasks, those are threads because you're sharing address space. If you are completely independent of another process, well, that's a process. Okay, how we doing?
It's helping me understand it a bit more.
Okay. So with the C++, with respect to Project 5, there'll be the launch of the thread by calling the constructor. And that would be typically done by saying new thread. And that's going to return a pointer, like anything from with new, that's going to return a pointer to the thread. Later on, in order to lay the thread to rest, somebody has to do a join. So let me be more clear about this. So some executing agent, which is probably the first thread in your process, creates more threads. Then somebody then has to collect their souls, their bodies, when they're finished. That's what join does.
But does it free them automatically?
I'm sorry?
Does it automatically free them?
Free them.
As in when you alloc something, you then have to free it.
Actually, you do have to delete threads, right? If you do a new, anything you do a new with, you have to delete. There is an exception to that, by the way, which this is a whole school of thought. Some professors teach that it's okay to lose memory.
You disagree.
I disagree. The fucking patient died because you leaked memory. All right, so no, I'm not in that school of thought, but I do recognize there's one exception that's quite reasonable. Let's say you've malloc or nude billions of bytes of memory, and now your program is ready to exit. Special case now, your program is ready to exit. Now you could free all those billions of bytes and then exit. But it turns out in some applications, exiting might take several seconds of doing freeze, when all you're going to do at the end of that is exit. So the one exception that I tolerate for with respect to memory management is if the next thing you're going to do is exit, then I tolerate you not freeing what you allocated. Cephas, you got a comment?
Yeah, I've always thought about that. If the OS is going to clean the memory for you, I don't see any reason in doing it yourself.
Correct. So I have the same attitude. Now, but what we're talking about though, is a program that's about to exit. If that's not the case, then you're leaking memory and the patient may be killed because you did so. You know, and I don't mind sounding dramatic because this actually happens. We coders are the guardians of the friggin' new world, right? When we screw up, people will die. So don't screw up. Screw up in your own way, right? Don't screw up in an easily preventable way. Some of you might be saying, well, I'm not going to work on a heart rate, a heart monitor. I'm not going to work on a pacemaker. I'm not going to work on an avionics system. So why do I need to be so dramatic? Well, let's say all you're working on was a stupid electronic grading system for an exam. I mean, what the hell, right? What's the big risk there? Well, in India, a couple of years ago, there was a bug in the software that was doing their national exam grading. People got low scores, so they killed themselves. So don't tell me there's no possibility that lives are not on the line on that silly web front end that you're coding.
No, let's just say you're the UI programmer for React native application or something. It's just some random blog. Nobody cares.
Well, my point is you should always be programming like somebody's life depends upon it.
I suppose it's a good rule of thumb, but there are definitely things that you program that really don't matter.
Well, like the programs you write for school, they really don't matter, except to the professor who cares enough to give you a failing grade. Not you. When I say you, I don't mean you. I mean you in the general sense. So it's when I give you a 0, it's because I love you.
Odd way of showing it, but sure.
Is it because you just want to say you messed up, this is why, now fix it?
Well, in this class, I'm definitely giving you the opportunity to fix it.
You're supposed to learn from your failures, not accept them.
Right. Okay.
Like, I know I'm slower at figuring things out, so sometimes I'm like, I need the time to fail in order so I can succeed later.
Good. And you need somebody to tell you about the failure so you can learn from it.
Although in fairness, at least when it comes to me, your comments are a little bit vague and not particularly instructive.
That's because you're Cephas.
Well,
Maybe it is.
Have you ever seen the David Carradine 1970s show Kung Fu?
No.
I think
Okay.
we should.
Well, David Carradine plays a character who is has gone through the process of becoming a Shaolin monk, and every time he asks for advice from the senior monks, they always talk in parables. So that's what I'm doing with you, Cephas.
Funnily enough, I think I've seen that show.
Professor, sometimes it does feel like you give us no rest between projects, so we can try and focus a little bit more. It's hard to say.
Okay. I know what you're saying. And you know what? The fucking real world doesn't give a shit.
I know. I know it doesn't. I know that it doesn't. You don't need to remind me.
Yeah. No, why is a medical residency the way it is? Right? Because that's the real world. So, think about your college education, your time in college here in learning computer science. This is the ideal time for you to fail. This is the lowest consequence, lowest cost time to fail in the rest of your life. So, here is where your teachers should not be coddling you, because you won't be coddled when you leave college.
I agree that it's the best time to fail, but I do not agree that it's the lowest cost, because if you fail a class and you have to take it again, that class is pretty expensive. It's definitely the best time to fail because there's
Okay.
advice, Like
Well, Nate,
if you messed up your job, they just fire you. They wouldn't tell you why they're firing you. They'd just fire you,
mhm. Yeah, Nate, I stand corrected. I see what you're saying.
Yeah. But the figure of speech still makes sense.
Uh, okay. So any questions? Because I still want to get back to the work that's ahead of us.
So for P6, how long is the buffer? How big do you want the buffer to be?
The buffer is determined by the user on the command line. The buffer is any size whatsoever.
Oh, yep.
Okay. Now I did add a feature to my main.cpp, which I didn't document in the spec. So there's -L, and that is is that the size? Did I say that that's the length?
Yes.
Okay.
Num bytes.
Right, num bytes. Now I added to main.cpp, which is code that I provided to you that you don't have to worry about really, but I did add a feature that I didn't document, and that's -L. And that is a shorthand way of doing num bytes. So this would be the exponent, 2 to the n. So if you specified -L10, that would be like saying 1024. And -L16 would be the same as specifying 65,536. Power of 2. Okay? Learn your damn powers of 2. It should be second nature to you. It's your profession, for God's sake. Okay, so anyway, the code is already given to you, but I did want to mention that there is that one feature that is not documented in the spec. Okay, other questions about P5, P6? All right, so we learned about fork. So in fork, one process comes in, one process calls fork, and 2 processes come out. And fork has this signature. The only difference between what we'll call the parent and what we'll call the child is the return value of fork. So in the parent, you know you're the parent because the return value that is returned by fork is not 0. And in the child, you know that you're the child because the PID is 0. Okay, so what I want to do for this class is I want you at your place of wherever it is that you are doing whatever it is that you're doing, I want you to write the code along with me. And I want you to write a program that, so if you ran it, ./a.out, and you said slash, this is the command line argument, /bin/ls. Clearly, you're going to be doing this on a Linux environment. It would actually run /bin/ls. So in other words, we're going to be learning about exec. Now, to start that, let's review the man page for exec. See, do I have a terminal running? No. Okay. Now, let me share this terminal. So if you say man exec, you get the wrong thing.
What should we be coding this in? ARM or C++?
You can code it in, no, yeah, not assembly language. Okay. Whenever I say not assembly language, I enjoy seeing this, the look of relief on Jordan's face. Okay, so if you say man exec, this is the wrong thing, right? This is exec is a keyword in one of the shells, one or more of the shells. So how about man3 exec? That's more like it. So you notice there's exec-L, exec-LE, exec-LP, CV, V, VP, V capital P. The difference between them is how you specify the program's environment, also how you pass along the command line parameters. Exec is how a program finds out about its argv. Exec is actually going to build argv. So, for example, well, first let's look about what they all have, what they have in common. Let's ignore LP and VP and V capital P. But looking at the others like L, LE, and V, you're giving it the path to an executable program. So going back to my iPad, when I wrote a.out/bin/ls, that is the path to an executable program on a Linux machine. Okay. Then following that will be the arguments that will become argv. So looking up here, here's a pointer to char for argument 0, a pointer to char for argument 1, 2, 3, etc., until you specify a null. So let's do this one, okay? Let's use exec-L, the most basic form. All right. So I think for simplicity's sake, I'll just code right here. Well, where am I? Let me go to /temp. Fork exec.cpp.
Do you not have Vim? Or do you just not like Vim?
Oh, this is Vim. It's just linked to VI.
Oh, why?
Yeah, this is Vim. Okay. We know that we're going to need uni-std.h, because that's where exec comes from. Okay. Have I made a mistake already?
You forgot to include argc argv in int main.
Right. I can't process, you can't process command line parameters unless you use the full form of main. Okay, so the usage of the program. So it's going to be, the name of your program, and then for now, it's going to be path to executable to run. Okay, with that said, what should I write next? Feel free to just talk.
You should check to see if argc is like using argc. You should check to see if something's actually supplied.
Good, good. And I might do it like this, right? Because I know I need at least, what's the minimum value of argc?
1.
Good. So if I have a command line option or argument, then it's going to be at least 2. Right? So if it's less than 2, it's bad. What are the 3 open files by default for every program?
Also, you forgot the close bracket for the if statement.
Yeah, I haven't gotten there yet. I'm asking you a question.
What was the question?
Could you repeat that?
What are the 3 files you have open by default on every program that runs?
Isn't CN, Cout, and
CR.
it's the program itself.
CR. Are you talking about file descriptors?
Yep, that's what I'm talking about. So, whoops. I wanted to make sure you knew about CERR. And that's where your error messages should go, not Cout. And where should, let's just call exit. In general, I do not love having more than one place of return from a function, but in this case, let's allow it. What is an exit code for a program that failed? Yeah, non-zero. Any idea what happens to that value?
It gets returned to the terminal?
It's returned to the parent, right? Because this process got launched by a parent. That's the only way processes get launched. Somebody launched this. That's the return code to whoever called you. All right. Now what?
Does that mean CERR is always the parent of the program you're working on?
No. CERR, let's switch here. So every process has in kernel memory, not your memory, not in your address space, every process has an open file table. Open file table. And the open file table is an array of things, black boxes. Really, they're pointers. So 0, 1, and 2 are by default special. This is going to correspond to std in, also known as cin. This one is std out.
Oh, right, Professor?
Yeah.
I forgot to use using namespace std in the code from a few seconds ago.
Oh, okay, I'll get back to it. Thanks.
He's not actually using that namespace so far anyway.
Okay, so file descriptor. 0 is your standard input. File descriptor 1 is your standard output. File descriptor 2 is your standard error output. Okay? So these are by default present on all programs that get launched. No, I've got the using namespace in there.
Guess I missed it then.
No problem.
Will you
Okay,
actually
so,
use STD?
I don't know if I will or I won't. Well, actually I am, right? Because I use Sierra.
No, but isn't, I guess.
Okay, what do I need to do next?
Else.
Hmm?
Oh no, well, you exit. I just kidding. You don't need to do else because you exit there.
Right.
So then you'd want to
For
Oh,
unless you actually want to replace
wouldn't
this
we need a
current process.
case in case the person is asking to access something that isn't there?
Well, we'll find out. We'll find out. All right, I think Cephas was either giving the correct answer or was cursing to himself.
Yes, both. We need to
Okay.
fork a process.
All right, well, how about this? Okay, now tell me how to tell the difference between child and parent.
The return value of PID type.
So if I want to know if I'm the child.
So if you want to know if you're the child, you'd say if process ID is equal to 0.
And let's shorten that by
Right.
saying if not process ID. Because 0 is the only thing that has the value of false. All right. So now we need our friend exec L. So help me out here. Where is the path to the program to be run?
argv1.
Good. And then I'm not passing along any other command, so any other arguments. So is this right?
I suppose. We're just going to pass in nothing as its argument. Wait, does LS need the, like, no, I don't think so.
Okay, hang on. Let's write what we've got so far and let's take a look. So I need the path. And look at that. It says that argv sub 0 has to be given because look, the ... happens next. So what is always the first argument in argv?
A.out.
The name
The
of the
name
program.
of the program. All right. So what goes here could be exactly the same as where? All
Wouldn't it
right.
be
Now let's, what?
Why is it argv1 instead of argv0?
Well, over here, argv1 is going to become that program's argv0.
What? Can you say that again?
My argv1 is going to become the program that I'm execing, argv0.
Okay, I see now.
All right, in fact, let's make this C error.
Okay, LLDB is complaining about passing a null pointer. You might have to use null. I'm not sure.
Oh, okay, I don't care. There.
It works for me.
Okay, let's try this program. Okay, please specify a program to run and /bin/ls. Okay, well, at the top of this, let's see what it says. The parent launched child 68708 and said goodbye. The child, so this is 68708, says, I'm about to launch bin ls. And oh, looky there. There's the /bin/ls of my temp directory. That's where I am right now. So it's a lot of crap. Okay, does the program work for you?
No. I get the message child about to launch and /bin/ls, and then nothing happens.
Okay. What computer system are you on right now? Are you on Whizzle?
I'm on a Mac.
Okay, so this should work, no problem. Yeah, so how about you share your code?
Happily.
Should we be running this through the Mac or ARM terminal?
Through the Mac terminal is fine.
That might. Can you allow me to share my screen?
Oh, I didn't already? You're right, I didn't. Oh, goodness. Go ahead.
Ready. So I'll just do this. Is it because I'm in a folder by chance?
To me, it looks like it did the work. Go ahead and run your program. Okay, it did exactly what it's supposed to do, Jordan. Hit return.
Oh. Okay.
Yeah, so your shell is the parent. I'm sorry. The program that you wrote, that we wrote here, is the parent of the child. The child is going to run /bin/ls. But notice immediately after the if statement, the parent says, I'm the parent, I'm out of here. So the parent of this program is the shell. That's why you get the shell prompt back.
Oh, that makes sense.
And then in its own sweet time, /bin/ls runs. So that's why you get the rest of that gibberish. So now try for me. I'm sorry, I can present, doesn't matter.
Okay, I didn't know if you wanted me to continue or not.
Yeah.
Okay.
That's all right. So, okay, so now let's do, this is a question for Rebecca. Rebecca said, well, we have to know whether or not the thing that we want to exec to is real or not. So I said we'd find out. So here's, I want to exec to a program that doesn't exist. Okay, something bad happened. That's the only way exec can return, is if the exec fails. Okay?
I see. Okay, I see what it was doing.
Okay. Now, let's see. Is there? Okay, good. But I need to give it up.
I found a bit of a bug, and can you explain to me why it doesn't work?
You
So-
found the bug.
I found a sort of a bug.
Okay, show us your code.
Well, I don't think I'm just curious why it doesn't work. I do, instead of, share my screen. There. So I launched CD instead of, I launched CD instead of LS. And
which CD?
Well, I know it's coming, but what happens?
well, so up here it ran like twice. It says something bad happened. Why does it say
which CD?
Well, if I just do CD, it'll exit the folder, right?
Yeah.
It
I
goes
say
to the-
type which CD, as in
Yep, that's
WICH.
That's
CD.
exactly what I was going to ask Jordan to do. So Cephas has got it.
which CD?
Mm-hmm.
Yes. It doesn't exist. I'm confused now.
In class.
Okay, now try saying man CD. Oh, what computer? Oh, you're on your, I'm sorry, you're on your ARM machine. So let me do that. And you'll see why it behaved that way. So man CD.
Wait, it works for me. It's in user bin CD. So why did it work on the ARM machine?
Okay, well, anyway, CD is a built-in to the shell. So it's your parent shell that's processing it, not a real program. You have a /bin/CD.
Wait, I have user /bin CD. Is that just a Mac thing or is it lying to me?
It should be a built-in, and you notice how I'm presenting my screen. It says it's a shell built-in.
Ah, so I use both Zish and a shell called Fish. So perhaps Fish made an actual program? I don't know.
I don't know. But CD is built into the shell, so it's processed internally by the shell. Okay, now it's 1:48. I think we have time for some more. Why don't we explore one of the cousins of execl? So man3 exec. Let's use exec v. Take a look at exec v. So what's different about exec L and exec V?
It doesn't take any more parameters than just argv and path.
Well, au contraire, it does take more arguments. It's just that the arguments, additional arguments, are going to be packaged in an array. Just like how your program gets argv in an array. So now I want you to modify this program so it can take any number of command line arguments, and it feeds all the excess to the child.
All the access.
Right. Okay, so now we're changing this to optional arg1, arg2, arg3, etc. So now, for example, when I say /bin/ls, I should be able to specify /bin/ls-l. So I can send that -l to be the argument to /bin/ls. Okay. So here, you need exec v instead of L, plus setup.
We're going to assume that our program takes X number of arguments, and then every argument besides that is going to be passed into the one we're
Correct.
executing.
Right.
So in this case, we don't take any extra arguments for our main program. So we're just
No,
going to
we
pass
do. We do. I want to be able to say something like this. I want to be able to say a.out /bin/ls -l. Right now, that -l is going to be ignored. Okay. I want to be able to process that now. So what does exec v take? Exec v is going to take char star, and then it's going to take a char star star. Look at that, char star star, and over here, char star star. So you know what that is. Tell me how to write it.
just increment the pointer. Well, displace the pointer by, I guess, 1, since main only takes 1 argument.
That's a pretty cool idea. Let's try that. I think I understood what you meant. So exec v, arg v 1, and then what should I put here?
Arg v plus 1. Since
not exactly.
Why not? We're just incrementing the pointer. And main only takes 1 parameter, which is its name. Right? Normally
Okay.
something.
Wait, here's what I think you meant, which is a cool idea. I'm not sure it's going to work, but let's try it. It would be the address of arg v sub 1.
Well, that's the same thing as in manually incrementing it. Well, displacing it, but yeah.
All right, let's try it. I'm not sure it's going to work.
Wait. I don't think it would work, because argv, the address would be the address of the value itself, right? I don't think that should.
Well, let's see if the base case works. That worked. Let's see if this works. Oh, it does work. Good idea, Cephas, even though you didn't think it would work. So how about /a.out slash bin slash ls slash, I'm going to give it dash L and squiggle. Let's see what it does. Look at that. It did exactly the right thing. Now, this isn't how I was going to do it. So Cephas he doesn't know he had a good idea, but he did, which is usually the case. Ha ha ha. I'm kidding. So why did this work?
Well, this little bracket notation is just essentially incrementing the memory we're pointing to by whatever the size of argv is, which in this case is char, and then we're just guessing the memory address of that, which is going to be displaced by that much from the original pointer, which is excluding this main thingy. Yeah, I didn't think I explained that particularly well, but I get what's happening.
Okay, but does anybody else get what's happening?
Not everybody at once, gosh.
Okay. So here is my shell. Here's what's happening. Here's my shell. And it's going to call fork and then exec v. And the first argument is going to be that ./a.out. And then the second argument is going to be an array, which it has assembled. What does that array look like? And the command line was this. Okay, that's what I typed in. So the array that the shell constructs, this is what I thought I was going to implement with you, is going to be, it is a char star star, which means that at index 0, there is a pointer to ./a.out, followed by, at index 1, a pointer to, well, it turns out the same place. Okay, I just had a mental fart. Where am I? I'm the shell. Oh yeah, okay. I remembered where I am. Okay, this is a pointer to a string /bin/ls. And then this is a pointer at index 2 is a pointer to a tilde. And then this at index 3 is a 0. Now this is the shell. The shell constructs this array. It does a new, how many bytes long? There's space for 4 pointers. Each pointer is worth 8 bytes. So this is 32 bytes, right? So the shell did a malloc of 32 bytes and then filled it in the way you see it here, as if they were all char stars. Okay. Now, when my program runs a.out, it's getting its argv looks exactly like that. In fact, that's exactly what it's getting. Okay, a pointer to tilde and a pointer to -l. No, it's getting one more. Pointer to /bin/ls and a pointer here. It's a pointer to /bin/ls.
Could I ask something?
Yeah.
So since you're passing a reference to argv 1, does that account for skipping over a dot out, or does it still include a dot out in that
No,
memory
it's
allocation?
skipping a dot out because that's the appropriate first argument for a dot out. But
Mhm.
that path/bin/ls is the appropriate argument for the child. So
Okay.
we're cheating. What this comes down to, and the reason why I'm so tickled by it, is we're reusing a dot out's array constructed for it by the shell. We're reusing it and sending it to the child.
Wait, couldn't we just do argv plus 1 instead? Because I'm reasonably certain this is the same thing as saying argv plus 1.
Okay. So yeah, argv plus 1. And you're right, that is the same thing. Yep, you're right.
Nice, that makes me feel better.
It makes you feel better. Okay. So yeah, Cephas, I thought this was really cute because you're reusing somebody else's array.
What was your initial plan of doing it?
I would have done what the shell does, which would be to count up number of arguments needed. This is literally what the shell does. Malloc enough space for that many pointers plus 1. Then it would malloc space for each string, copy each string, set last one to 0, and then do the exec. This is literally what the shell does. So that's what I was going to do, but Cephas's idea was much shorter.
I understand the malloc enough space for that many pointers plus 1, but where does it malloc space for each string? Like, because I understand allocating like the 32 bytes for the 4 pointers. That completely makes sense to me. But then on top of that, malloc space for each string, probably for each char star, right, in the char star star.
Mhm.
So can you just like briefly write how you go about doing that specifically, or how the shell does it?
Okay, well, suppose
Wouldn't you have to read until... Yeah, you'd have to read this current argv until to get all the sizes, right? To do a proper malloc.
So
That seems tedious.
for example, int arg counter equals 1, let's say. Arg counter less than argc. Arg counter plus plus. And then let's say size t size needed equals strlen of star arg of argv sub arg counter. All right, so that's how many non-nulls there are. And so let's take care of the null right here, plus 1. So that's how many non-nulls there are in the original string. We need to add 1 for the null. And then how about strcpy? Oh, I didn't malloc yet, did I? Malloc. And then strcpy. Now there's an easier way to do this. And that is with a function called strdup. Strdup does the malloc for you. And the copy. Okay, and it would do that for each and every. Finally, you got to make sure that, well, I didn't show the code that allocates the array itself. Ensure last member is 0, and then the exec. Now, if you're the parent, then you can start freeing things. All right, only 5 minutes left. Questions? What did you learn today?
Quite
One
a
thing you
lot.
learned is 2 to the 20th isn't fucking a million.
It most
Okay.
definitely is not.
All right. What, Jordan, you were going to say something else that we learned?
No, I was just going to say we learned a lot.
Okay, good. So we got some practice on the concept of fork. We tried out exec and one of its cousins. By the way, the very first project in operating systems is to write a shell. A simplified shell, but it's a shell. Cephas did very well on that, right? Do you remember that project?
No, we didn't write a shell, at least not in my year.
Yeah, you did. Project 1.
No. Project 1 was implementing
A system call.
Yeah, a system call.
Yeah, that was the first XV6 project.
Yeah.
Well, I think
Most everything we did in. Wait, we didn't write a shell. Did we write it? I don't remember. We did not write a shell. Bet.
Tell you what.
I would remember that.
All right. You're challenging me. So let's go. This is what I did for you folks last year in OS, and I'll do it again for you this year. Search for summer. The summer OS Head Start. Check this out. You will have the summer. How many people here are taking the class next fall? Just one? Okay, I know Morgan's not, but maybe
Yeah, me too.
Neto, maybe Nate, maybe Jacob, Jordan, Thomas. Okay, so you'll have access to this. And let's see, what's this? Named pipe implementation, nobody did that. Nobody did that. Actually, I gave this available to everybody and nobody did any of them.
Lie, I did.
You did? Good.
Yes, I
I
did.
looked at them. I remember I looked at them last year and promptly closed it because I had no clue what was happening.
Yeah.
We
All
did
right,
not
so-
implement a shell. Bet.
Well, maybe you're right.
I'm definitely right. I would remember.
Let's see.
I would have
In
made
this
something
user.
cool.
What the heck? Give me a break, man. All right, so go here and go here. And now search for fork. Whoops, this one is deprecated.
We didn't do it.
See PK shell. We didn't do this project? Are you sure?
I would remember that.
Okay, well, this is your first project for next year.
4730. Why do they get to implement a shell?
You sure I didn't start with this?
I bet you money. Bet you money. We did not do this.
Okay. Yeah,
I
look
mean,
at
the
that. There's-
specs are there if you want to make a shell.
Yeah.
I'll call it the storm shell. Storm SF.
Okay, so
It's gonna
yeah,
be
Storm
awesome.
Shell, that's fine. So for the folks taking operating systems next year, I'm going to put at least 4 of your projects online in full, and you can work on them in the summer. You can even ask me questions. But I know that when it comes time for fall, basically nobody will have done so. So I hope I'm wrong.
In fairness, you're asking people to complete a project for a class they have not taken and probably have no idea what the heck is going on. And despite how attractive it is to look on Stack Overflow for 15 hours, most people would prefer not to do that with their summer.
Well, maybe that says that the way that your generation goes about learning things is wrong. Maybe going to Stack Overflow is not the most expeditious way of learning something.
Yeah, I can definitely agree with that statement.
Yeah.
That's just
Right,
because you
right.
have personal issues with Stack Overflow, Tony.
Yeah, I never find anything useful, except for
Yeah.
the 2 times I've actually found something of use after a
You are
long time of
literally-
searching.
You are the first person I've ever met who has an issue with Stack Overflow.
Oh, I hate Stack Overflow. So it's the second person you've met. Stack Overflow is where programmers go to be insulted.
I mean, I think you would like it. A
that,
lot of the people seem just like you.
What?
A lot of I would think you would like Stack Overflow. It has your vibe. It's like, you don't get it right? Well, F you. Learn it.
Okay.
Yeah,
It's,
So anyway,
you are
take a
kind
look
of
here.
like this.
Given just what you see here, this is enough for you to do the project. You'd go home and you say, okay, let me look up fork. Okay, got it. Let me look up exec, look up pipe, redirection. Damn it, there's a Wikipedia page on redirection. So if all I gave you is this is enough for you to learn. You know, you guys have it too easy.
I mean, technically, I could buy a book on, I don't know, Vulkan, and everything in there that I would need to use Vulkan is there. That doesn't mean I'm going to be able to learn a Vulkan from a book. It's more difficult than just that.
But it sounds like you're of a mindset, that the teacher has to explain everything.
I am definitely not. I have learned most of my shenanigans from my own research. I think you know me well enough to know that. But there is a reason why colleges exist and why everybody isn't learning arcane, complicated subject matter from
if
books and the internet.
if we had to do all of our own research for this class, why would we even take this class? We would just do it online for free.
Yeah. What I'm doing, by the way, class is over. But what I'm doing is in part teaching you how to learn. Right?
It works for some people. Like, again, I learn most stuff by myself, but for others, it is considerably more difficult.
Okay. Well, what we're discussing is the fact that you'll have May, June, July, and August to do the projects for fall. That's what I'm saying. You got 4 extra months. So no extra deadline, no pushing the deadlines. Okay, so as soon as you register for operating systems, I'll email the class the link for the projects. And besides, you can ask questions. And class is over. I think it was a good class. I got to curse a lot, so I'm happy. And I got to berate you, but it's only because I care. All right. So I'll see you probably tonight, maybe at the barbecue. If not, I'll see you next week.